Hello viewers, welcome back. Today we will discuss about totalizer, flow totalizer. We are generally use in the plant the liquid flow meter, gas flow meter or solid flow meter. In this flow meter has a flow rate at liter per minute or ton per hour, ton per minute like this or meter cube per hour. So how we can calculate this total value pass or total material used in the system? If the flow rate is constant like 50 liter per minute, then we can easily tell that in 1 minute liquid use 50 liter. For 10 minutes it is 500 liter. But if the value is fluctuate or change with time, then it is not easy to calculate. See here you can see the flow trend that it is changing with time. Here is the time axis and here is the value, flow rate value. So it is not easy to calculate the total material flow or total material used in the system. To do that, we have to sampling the input signal, flow rate signal in a small time. If your sample rate is less, then your value may have the error. But if your sample rate is high, then your value will be more accurate. Here we can take a value, or you can take here, or we can take here, or you can take here. Then the value will be more accurate. But if we take the sample from here, then here, then here, then there will be miss here. So we will take a sample as less as much possible. So we have a 3 input to calculate the total material flow. One is the value, another is the total unit, that means ton per hour, then hour is the time periodic unit, or liter per minute is the periodic unit, and another is the sampling frequency, sampling time. Let's make a function. I will make a function block in SCL language. Give a name as totalizer FB, and in a language SCL. Okay, so I want to use this function block again and again, because in a plant maybe there are several number of flow meter. So if you make a totalizer function or function block, then it will be easy to call and reuse it. So I'm making a function block. There is a main 3 input. One is called flow, and if you want to use the flow directly from the milliamps to this function block, then you have to make the input as a integer, then you have to convert this integer to real. I want to use this flow input as a real, which is SCL in other function. So input is a real, and another input is a period. That is a time. That is a time. And another is a cycle. Sampling cycle, sampling frequency. Okay. Now output will be total material, or you can make call as total, and this value also in a real fractional value. Okay, now here if you want to calculate the total, so all units should be in same, but here period is in time and flow is in real. So I want to make a total material flow, and that is in real data type. So we have to make the period data type in real. Period in real real real, but you cannot convert the time directly to real. Yes, you can. Okay, in we don't need another block, another tag. We can make in and another is cycle in real. Okay, now here first we have to convert the period period in real. So period in real equal to, first we have to convert the time to din, because it is not possible to convert the uh, time to real. First we have to convert time to din, then din to real. So time to din again equal to time to din to real n equal to your period. So din to real, so you cannot convert in this way, so you have to make another so I am creating a creating a tag that called as a period in din, because we have to convert the time into double integer first, then double integer to real, and then we will use that into real period in real format in our calculation, in our equation. Same way we will create the in dint and cycle in real. Okay, period in din which input the time to din, and the input of this time to din function is period. Okay, then we want to convert this din to real. Period and output will be period in real, and function we will use d into real, and into input of this function is period in din. Same way we will convert the cycle time into real. In that input of this function is cycle, and cycle in real is output is time to real, d into real, and into input of this function is cycle in din. Okay, now the equation will be total equation will be our flow. Suppose this flow is in hour, so we have to divided that flow rate with this period, then multiply with the sample time. Period in real then multiply with cycle time, cycle in real. So it will calculate like this, but we want to accumulate this value. It will calculate in every scan cycle, but it will not accumulate. To accumulate with the previous value, we have give a total here. First cycle total value will be 0 to some value, and second cycle total value will be this value with that sum first cycle value. To give a name of this flow meter, we can use another input as a string, which will not use for calculation, but just for name purpose, description purpose. So I am give a string 50 string to give a name. Okay, we may have another input that we want to reset the totalizer value, so we have to give another input that reset, that to reset the totalizer value, the reset pin should be a bool. Okay, now how we can use the reset? We will use the if instruction, that if reset is true, then total will be total value will be 0, else it will calculate total value and store in total, else and if okay, this is our totalizer function. Okay, now we will call this function and execute in OB1 function block. Now function totalizer okay, we are calling this function in here, and function block will, when you create a function block, it will generate a instance db. When you call a function block in a function or OB, that time it will generate a instance db, because function block will use its own storage stack. Okay, now see, it is looks like this. You can give a name here, oil inlet, and you have you have to give a single inverted comma. Okay, oil inlet. Then if you have a 50 liter per minute flow, then your period will be 1 minute. Okay, if you want to sample the flow rate input in 100 millisecond, every 100 millisecond, then your cycle time will be 100 millisecond. And for reset of your input, you can use any signal, any boolean signal. I am using the 0 like this. Okay, calling the reset. Okay, now I will call this function in OB initialize. Okay, now going online and monitor. See, it is calculate to mass, but in a minute it should be 50. But why it is more? Because you have gave a 100 millisecond cycle, but your execution cycle your execution cycle is less than 1 millisecond. So in every in every cycle accumulate the value several time. So we'll give a pulse here for 100 milliseconds. Here we have used a cycle time 100 milliseconds, so we'll use a 100 millisecond pulse of system clock, and that input is 1.0. Okay, but download it again. Now it is not much improved because this pulse is 100 millisecond duration. 100 every 100 millisecond it will give a pulse for 100 milliseconds. So we'll use another instruction called ptick, which will give a only one pulse, only one pulse if input is high of this ptick clock. So we download it again. It is not adding so fast now. Now I am resetting the value again, going 0. Now in 1 minute the value should be in 50. We are waiting for 30 seconds. In the 30 seconds, okay, we can use a clock. Again reset. Value maybe deeper because this is a simulation PLC. It is not faster the physical PLC. So value may differs. Let's see. In 30 seconds it should be 25 or near about. It is 25 because we have start the timer little bit less later. We have start the time little bit later, that's why it is the total value more than 30 to more than 25. Now we'll see in 1 minute, and this value should be 50. Yes.